let's look at sequential search in this video. So sequential search is the most basic way to search for a target inside of a collection. And sequential search starts at the beginning of the collection and examines each element in the collection to see if it's equal to the target. So it starts at the beginning, goes all the way through the end. So it's traversing through the collection. Sequential search returns the first index that the target is in, or -1 if the target was not in the collection. And sequential search does not require the collection to be sorted. So sequential search works regardless whether it's sorted or not sorted. It doesn't matter. Sequential search works one way or the other. So sequential search receives as parameters the array and target and returns an int. So we start by looking at whether the array's length is equal to 0. If the array length is equal to 0, we return -1. Otherwise, we're going to iterate through the array. If we ever find the target, we return index I. Otherwise, we return -1 because we didn't find it in the array. Big O notation. Now, we use big O notation to classify algorithms by how fast they're able to work based on an input size. Now, our input size is going to be a collection of size n. So sequential search is O of n. It's linear time. Its best case is O of 1. We found it in the first try. Worst case, we had to traverse through the whole thing. It's either the last element or it was not in the collection. So let's examine how sequential search is going to work. So here are our arrays. So notice they're not sorted. So if I'm looking for 7, and I call this, it's going to take index 0, 1, 2, 3. So it's going to return index 3. It took 4 comparisons to do that. If I'm looking for 4, 0, 1, it's going to return 1. It took 2 comparisons. If I'm looking for 0, 0, 1, 2, 3, 4, 5, it's not in there. So it returns a -1, and that took a total of 6 comparisons. Now, the speed of sequential search can be improved if the collection is sorted. The algorithm can stop the search if it finds a target or if everything is greater than the target. Thus, it can't be in the collection. So here, A is sorted. So if I'm looking for 6, 2, 4, 5, 7, oh, I know I can stop here at 7 because I'm looking for 6. And if this is sorted, it can't be anything past that. So it's going to return -1 after index 2 because it's like, hey, index 3 is 7. It can't be that. So this took a total of 4 comparisons. So it became a little bit more efficient, but not as efficient as potentially a searching technique could be. Binary search ends up being significantly more efficient. But, like I said, sequential search can be more efficient given a sorted array, sorted collection. And that is the end of this lesson.